Sometimes it plays that noise, sometimes it doesn't. But now we know it's recording at least. So still Mrs. Ho, still second out. These are our special cases of variables on both sides. There are going to be two things that happen, and then if one of those happens, there's going to be another thing that happens as a result of that. Two more options after that. So we have a little flow chart here. The first thing that's going to happen is that you are going to be able to solve for x. So this is going to be what we just did in 1.6. So that is not even anything new we're learning, because that's what you literally just did. So if you are able to solve for x, you are going to do it. So if you are able to solve for x, you do need to solve for x. You are going to end up having one solution. And you need to write down what that solution is. It's always going to be x equals a number. So every single equation we've solved so far has had one solution. Our inequalities have an array of solutions. But everything except for 1.3, 1.12, 4, 5, 6, every single problem you've had has had one solution. What's new with these special cases is going to be our variables disappearing. So the other thing that might happen, you aren't going to be able to solve for x. Your variables are going to disappear. You can't just erase them or cross them out. They have to actually mathematically disappear. After your variables disappear, you are going to be left with a mathematical statement. A number equals a number. That statement is going to be either true, that's what's going to go in my top arrow, or false. So a true statement would be something like 5 equals 5. That is true. The quick write, negative 32 equals negative 32. Does anyone remember, if you are left with a true statement, what your answer is?
0.
That's a number. We don't have a solution. Well, actually, we have so many solutions. I had you guys plug in 24. We plugged in 67. We could have plugged in any other number. Every single number is a solution to this equation. No? Infinite. So if your variables disappear and you are left with a true statement, you have infinite solutions. So you can write the word infinite out. Infinite solutions. Or if you want to shorthand it, you can write an infinity sign, SOL. Or you can write INF, SOL. We will understand what all of those mean. Don't just write down infinity. Because your answer is not infinity. Your answer is that there is an infinite number of solutions. So, any of those work. You don't have to write those all down. You can write whichever one you're going to write. That makes sense to you. Okay. If your variables disappear and you are left with a false statement, something like 7 equals 12, 67 equals 41, that's never going to be true. You are going to have no solution. So you can write down no solution, or you can write down no SOL. Don't just write down the word no, because to me that just says, nope, not going to do it. Okay, any questions about either of those or any of that flow chart? Okay, so now we're going to use that flow chart for our examples. Coriana, I know you're getting caught up. Pause. Put your cram book away. Pay attention to this. You can't fall more behind. All right, so the very first one is your quick write. Look, I stole that. So we are going to start by distributing. So we'll distribute 4 to the x and 4 to the negative 8. So on the left, I still have 4x minus 32. On the right, 4 to the x was 4x. 4 to the negative 8 was negative 32. Okay. especially for these problems, now that these funky things are going to happen, do not move your constants yet. Move your x's, because if your x's are going to cancel out, there's no use wasting time moving your constants, and that gives you another chance of making a mistake. So just move your x's first. So I'm going to subtract the 4x from both sides like I did. And those now cancel out. So those cancel out. I've just got negative 32. Those cancel out. I've just got negative 32. Okay. Does negative 32 equal negative 32? Yes, that is a true statement. So I'm going to write in parentheses that that's a true statement. That is not your answer. Your answer is not true. Your answer is that we have infinite solutions because that is true. So the actual answer you need written down on your paper is infinite solutions. So you need to show you're distributing, things canceling out, infinite solutions. If you want to write down that it's true, you can. But the two things that you're going to need are your work and your infinite solutions. Okay. Any questions right now? All right. Next one then. We need to combine like terms on both sides. So on the left side of this equal sign, I can combine together my 2x and my 3x to get 5x. Still have plus 4 equals. On the right side, 7x minus 2x, also 5x, plus 6. Okay, what should my next step be? Get rid of my x's, subtract the x's. So I'm going to subtract 5x, I'm going to subtract 5x. Those are now gone. Scram, scram. So I now have 4 equals 6. Does 4 equal 6? No. So I'm going to put a little note to myself that that is false. My answer is not false. My answer is no solutions. Hey, any questions right now? God, you have to use a screwdriver to get the battery out of this? It's never going to happen. Hey, flip this over then. We have 2 more problems on the back. The reason why we have 2 more problems is I want to remind you that sometimes you're going to get infinite solutions, sometimes you're going to get no solutions. Sometimes you will still get a solution. So, left one, we're going to distribute on the left side. 3 times 4x is 12x. 3 times 6 is 18. And that equals 8x plus 38. Okay, so this is like what you were just working on your assignments. We are able to solve for x, so we need to do it. So right now, I have a choice of subtracting 12x or 8x. I'm going to subtract 8x. I get 4x plus 18 equals, on the right side I have 38. I subtract 18 from both sides. I get 4x equals 38 minus 18 is 20. Divide both sides by 4. I get x equals 20 divided by 4 is 5. Okay, how many solutions do I have here? 1. What is that solution? 5. So you do not need to write down one solution because you're going to write down your solution. But if you want to, you can. Just understand, we've been getting one solution this entire time. Okay. Any questions on that guy? Okay, I have one more problem. and this is like, it's not a trick question, but it throws people off now that we've talked about having no solutions. So pay good attention to this one. On the left side, what do I need to do? Combine my like terms. So I've got this 4x and this negative 2x that can get combined together. So it'll give me 2x plus 15 equals. On the right side, what do I need to do? Distribute. 3 times 2x is 6x. 3 times 5 is 15. Okay. We could go either way. We could subtract 2x or subtract 6x. What do you want to do? The 2x? Okay, let's do it then. We're going to subtract 2x from both sides. On the left side, those cancel out and we have 15. On the right side, 6x minus 2x is 4x. And I have plus 15. What would be the next step of solving this equation? Yes. Move the 15, subtract 15. Yes. Everything all three of you just said. So subtract 15 from both sides. On the left side of my equation, what do I have? 0. So those cancel out. We represent it with a 0. If you have nothing, there's 0. Okay? On the right side, we still have our 4x. Have our x's disappeared? No. So if your x does not disappear, you need to solve for x. So people see the number 0 and think, well, 0 means nothing, nothing means no means no solutions. Don't make those connections, okay? Don't make those assumptions. 0 means that our x is going to equal 0. So we'll divide both sides by 4 now. 0 divided by 4 is 0. So we have 0 equals x, or x equals 0. How many solutions do we have there? 1. What is that solution? 0. Okay? So you can have one solution that is x equals 0, which is completely different than having no solutions. Hey, any questions? Hey, I know we learned a lot of new stuff today, but the second set of notes was really just adding in that no solution and infinite solution.